Hello, my dear class 10 students. I hope you are all doing good, staying safe, healthy at home. My name is Ben, and I'll be taking your science. So today we'll start with first chapter, that is chemical reaction and chemical equation. Chemical reaction and chemical equation. So chemical reaction and chemical equation will be very interesting because it's very relatable in your everyday life, and together it will be very fun. So every day there are thousands of chemical reactions taking place in and around us. To start with, let's give an example. We can start from our own kitchen, that is conversion of milk to curd. I'm sure you all have seen a conversion of milk to curd, right? I'll give another example, that is rusting of iron. Rusting of iron. Let's give another example, that is digestion of food inside our body. This is also a chemical reaction. Digestion of food. And I can go on. We have lots of chemical reaction examples. But these are some examples. So to start with, there are two types of changes around us. There are two types of changes around us. Around us. So one is a physical change. And the other is a chemical change. So two types of changes around us. First, physical change. Second is a chemical change. What is a physical change? For a physical change, the definition is those type of change where no new substance are formed. Where no new substance are formed, I can give you an example of, just take a piece of paper. Everyone at your home, you can just take a piece of paper right now, and if you just tear it off, it will just be a paper. You won't get any new substance. Okay, now you have two pieces of paper after tearing it off, but it is still a paper. Clear? So we don't get any new paper. We don't get any new substance. So that will fall under a physical change, where you don't get any new substance. But let's look here, chemical change. Chemical change is those type of change where you'll get a new property or a new substance. Simple example, let's take another, again we'll take a paper, a piece of paper. If you just burn a pepper, you won't get a pepper anymore. What you'll get is you'll get a powdery form, a white remaining stuff you'll get. So now in that case we'll say that a chemical change has taken place, because now you don't have a pepper, it's not a pepper anymore, now it's a white powdery form is the remaining. So that will fall under a chemical change. So I'm sure you are clear with a physical change and a chemical change. So now we will study chemical reaction and the types of chemical equation. And I'm sure you're clear with our examples of the chemical reactions and whatever we have studied so far. Okay, so chemical reactions come under chemical change. Chemical reaction. So, and the definition of chemical reaction will be those involving a chemical change. those involving a chemical change. Those involving a chemical change will be the definition of chemical reaction, and you can write down any example, the previous example that I have written. So now, to start with, we'll begin with chemical equation. Chemical equation. Chemical equation. What is a chemical equation? Chemical equation is a symbolical representation of a chemical reaction. Let me tell you, in chemistry, we have 118 elements, 118 elements known in a modern periodic table. And all the 118 elements have their own short way of representation, or we'll say they have their own shortcut or symbol. Like most of you are class 10, so you like to text your friend, so you often like to use a shortcut. For thank you, now you won't write, you won't waste your time writing thank you. Most of you use TY. Or during exam time, while we check your paper, we often see this one, which means page turnover. Even for Nagaland, we use NL. For United Nations, we use UN. So chemistry, one very good thing about chemistry is, we always get the answer in a very simple form. Instead of all that sentence or in a long form, the answer at the end is very simple. Okay, so students, for all single 118 elements, they have their own symbol. Clear? Example for hydrogen. Hydrogen, the symbol is H. Let's take the second element, that is helium. Helium, it is He. The third element, lithium, it is Li. Next we have beryllium, Be. Next we have boron, B. So it goes on. So from 1 till 118 we have a symbol. Clear? Now, I'll give you an example of chemical equation. Let's say carbon dioxide. You are all familiar with carbon dioxide. So how do we get carbon dioxide? We can just write a word. In a word, we can write carbon reacts with oxygen to give carbon dioxide. Carbon dioxide. Carbon reacts with oxygen to give carbon dioxide. But as I have mentioned earlier, in chemistry, we always prefer to write the answer in a simple way, in a short way. So this further we can simplify in a shorter way, that is carbon, I can just write carbon, C-A-R-B-O-N, carbon plus oxygen gives carbon dioxide. So carbon and oxygen reacts to give carbon dioxide. So this type of equation is called a word equation, where this is much shorter than the first one. So this is in the form of a word equation. Carbon reacts with oxygen to give carbon dioxide. Now further this one we can again simplify into a much more simple one by just writing carbon, oxygen give carbon dioxide. Clear? So whenever you write oxygen, my dear students, whenever you write oxygen, you always have to write O2. Why? Because oxygen is a non-metal, it's a gas, and it is not stable. So just to make it more simple, it needs a backup. So you always have to write O2. Clear? So this is an example of a chemical equation. And the second one out here is an example of the word equation. Clear? So this we can write in this more simple way. So this is the example of chemical equation, and the definition of chemical equation is a symbolical representation of a chemical change. Clear? Symbolical representation of chemical change. Okay. Now, there are two types of chemical equation. Skeletal equation and balanced chemical equation. So students, how many types of chemical equation are there? Two types. Skeletal chemical equation and balanced chemical equation. So we will study that in details. So there are two types of chemical equation. There are two types of chemical equation. One, skeletal. Second, balanced chemical equation. So the first one is skeletal chemical equation, second is balanced chemical equation. So what do we mean by a skeletal chemical equation? Skeletal chemical equation means those equations which are not balanced. Which are not balanced. Clear? And the second one, balanced chemical equation means the equation which are balanced. So I'll give you example for the skeletal equation, that is hydrogen, oxygen, we have H2O. Now I have second example. This is example, okay, so over here this is the example for skeletal, and the example for the balanced chemical equation would be okay. So I have marked like this so that you can differentiate between skeletal and balanced chemical equation. So it's the same thing. We have the elements are same, hydrogen, oxygen, and then we have water. Hydrogen, oxygen, and then we have water. But now, everyone please pay attention and look here. Whatever we have on the left-hand side, this side, are known as reactant, okay? This is the reactant. Whatever we have on the left side of the equation is known as reactant. And whatever we have on the right side of the chemical equation is known as product. Reactant, product. Left-hand side, reactant. Right-hand side, product. Keep this in mind. So, to give you a very practical example, say, in order to make a tea, you need water, you need a sugar, you need a tea leaf, more. So, all the water, sugar, tea leaf falls under the category of reactant. And what is the result? At the end, you get tea. So that is the product. Clear? So I'm sure you have a basic idea of what is reactant and what is product. Clear? So now, in the reactant, let's see how many hydrogen are there? H2. Now, in the product, let's see how many hydrogen are there? 2. That means both in the reactant, both in the product, the hydrogen is equal, 2, 2, H2, H2. Now let's see oxygen in the reactant, it's O2, but look here in the product, we have only one oxygen. So that means oxygen is not balanced. So this equation is not balanced. So any chemical equation which is not equal or which is not balanced comes under the category of skeletal chemical equation. Skeletal. This is not skeleton. This is unbalanced. Clear? This is unbalanced. So they are opposite. So this is unbalanced. And now here, the second example here, you'll see that we have 4 hydrogen here, 2 into 2, 2 into 2. And then we have 2 oxygen here. And then we have 2 oxygen here. So that means everything is equal. So which out of these, which one is important? Skeletal or balance is important, or which one will you prefer? So the answer would be balanced chemical equation, because here it says that we need this much hydrogen, this much oxygen to give this much of water. But here it just says that hydrogen reacts with oxygen to give water. So this gives you an accurate amount. So this is more important. So if I'm sure you are clear with the basic difference between the skeletal and balanced chemical equation. If you are clear with this, we'll go to the next question, that is, why do we have to balance a chemical equation? Why do we have to balance a chemical equation? So the answer is very simple. Let's all remember what we have learned in class 9 physics. We have all learned the law of conservation of mass. I'm sure you have not forgotten, I guess, because in class 9 physics you have learned law of conservation of mass. So what does the law of conservation of mass says? Law of conservation of mass is very simple, where mass is not created nor destroyed, but it can be transformed from one form to another. So here, this is very important question, and I want all of you to note down, and I'm sure you are all ready with your paper, pen, or anything that is necessary. Okay, so question, you can write it down. Why do you have to balance a chemical equation? So I will not write the question, I'll just write the answer. Clear? I'll assume that you have written the question. So we have to balance the equation. A chemical equation needs to be balanced to obey the law of conservation of mass. So the answer is very simple. To obey the law of conservation of mass, where reactant and products will be equal. I'll give the same example again. So whatever we had, okay, the elements that we had in the left-hand side or in the reactant is not lost. We had this much amount of hydrogen in the reactant, that is not lost. Even in the product, we get to see this much hydrogen. Even in the product, what we are seeing, we have 4 hydrogen. Here we have 2 oxygen. Even in the product, we have 2 oxygen. So this equation obeys the law of conservation of mass, which says that nothing is destroyed. We did not create anything, nor we did not destroy anything. It has just been converted from one form to another. So this very question, please keep in mind, because this is very important, to obey the law of conservation of mass. Now, the next topic is how to balance a chemical equation. How to balance a chemical equation. So in exam, you'll be just given a word equation. From the word equation, you have to convert into a chemical equation, and then you need to balance. So any equation, you need to balance. So let's check now. Okay, I'll give you some example equation here. First, let's start with carbon and oxygen, which give carbon dioxide. Second, let's start with hydrogen and chlorine, which give hydrochloric acid. So I have 2 equations here, and our topic right now is how to balance a chemical equation. So in the textbook, we have around 7-8 steps. But I'll give you a very easy and simple trick so that you can solve this balancing chemical equation right away. So steps. So these are 3 steps, okay? I'll give you 3 steps. First, draw a box around each formula. First step would be to draw a box around each formula. Second, write the number of elements of both sides. That means we are going to write the number of elements on both sides. Both means left-hand side and the right-hand side, reactant and the product. The third one out here would be, this is the last step. Here we have to equalize the number of atoms on both sides, number of atoms on both sides. Now, in exam you will be given this type of equation. From this type of equation you will see whether they are balanced or not. If it's not balanced, you'll go ahead, you'll balance it. Clear? And how we'll balance? We'll use simple 3 steps. First, we'll draw a box around each formula. Second, we'll list the number of elements. And third, we will see that we will equalize the number. We'll make both left-hand side and right-hand side equal. Okay, so students, since I've given you 2 questions here, 2 chemical equations, we'll go and check this one out. So let's try the first question. So in exam time, you can just write this in your rough work. Clear? So let's draw 3 rows here. Okay. So I gave you 3 steps to balance a chemical equation. The first one, if you remember, is to draw a box around each formula. So let's draw a box in front of this carbon. Let's draw a box here. Let's draw a box here. So the first step is clear, done. Now the second step which I wrote is to list the number of elements of both the sides. So here we'll write number of elements. And here we'll write reactants, because in a chemical equation, if it's an equation, that means we have reactant and we have product. So we'll write here reactant, that is left hand side, and here we have product, that is right hand side. Clear? So in the first equation, let's list the number of elements. We have carbon, let's write here carbon. We have oxygen. So I'm sure you are clear till here. Whatever elements we have in this equation are carbon and oxygen. We don't have any other elements beside carbon and oxygen. CO, CO, C here, C over here, oxygen here. So just 2 elements, carbon, oxygen. Now let's see how many carbons are there in the left hand side. 1. Right? In the reactant, we get to see only 1 carbon. Now, in the product, how many carbons are there? In the product, we have CO2. That means we have 2 oxygen, but we have only 1 carbon. So, clear, done. Now, let's jump to oxygen. We have 2 oxygen here, and we have 2 oxygen on the reactant. On the reactant, we have 2 oxygen. So, does this obeys the law of conservation of mass? Yes, because the carbon is equal on both sides. Oxygen is equal on both sides. That means this equation obeys the law of conservation of mass. So this type of question also you might get where they have already balanced the chemical equation. So in this type of question, you say that you can just write that this equation is already balanced. Now let's go and see the second question, that is hydrogen, chlorine giving HCl. So what we'll list first, we'll list the elements here: hydrogen, chlorine. Okay. Now we'll draw the box here. Okay. So first 2 steps are done. Now, how many hydrogen are there in the reactant, students? This is hydrogen. Okay. So this one we are doing for the second question. So how many hydrogen are there in the reactant? 2. Now, how many chlorine are there in the reactant? 2. Let's jump to the product side. How many hydrogen are there? Only 1. How many chlorine are there? We have only 1 chlorine here. Clear? So that means it is not balanced. This type of equation where this and this are not equal, we call it as a skeletal. So that means this equation doesn't obey the law of conservation of mass. So what we'll do is we'll go ahead and we will balance this chemical equation. And so now we're applying the third step, that is equalize the number of atoms on both the sides. That's third step says equalize we have to make this and this equal. So we'll apply the third step. Now you have to remember that we can only use multiplication. Clear? We can only use multiplication. So hydrogen on the left hand side is 2. On the product we have 1. So how we'll make it equal? Simply by multiplying with 2. So 1 into 2 I get 2. Clear? Now the one very important thing, okay, here I have gone and I have make hydrogen 2 to make it balance. Because by any means we have to balance the equation. So I have added 2 here. I have added an extra 2 here. So whatever number we are putting here, we'll go and insert here. But here you have to remember that we cannot put before, or we cannot put after the formula. The number that you are adding here should always be added before the coefficient. Clear? Before the formula. So here I added 2. So I'll write here 2. Clear? We can never write the number here. Whatever number you're adding should always be added before, not after. So, but while adding this 2 here, even this chlorine becomes 2. Even this chlorine becomes 2. So now everything is balanced. Now we have 2, 2, 2, 2 on the reactant and on the product, everything is equal. Now this equation is already balanced. So this is not a skeletal equation anymore because we have already added another 2 here. So now left hand side and right hand side is equal. So this chemical equation is balanced. Okay, so I'll request you, we can go on. We have many questions like in the textbook. So I'll request you everyone to practice. And the next topic that we'll be studying is different types of chemical reaction, which is very important. Different types of chemical reaction. Okay, types of chemical reaction. The first type of chemical reaction that we will study is combination reaction. Combination reaction. Combination reaction. The second equation that we'll be studying is decomposition reaction. Decomposition reaction. The third type of reaction would be displacement reaction. Displacement reaction. Displacement reaction. The fourth type of reaction we'll study is double displacement. Double displacement. Now the fifth, okay, this will all be additional reaction. Okay, exothermic, endothermic, exothermic and endothermic reaction. And the last one here we have redox reaction. So under redox reaction we'll study oxidation as well as we'll study reduction. Clear? So my dear students, I want you all to be clear with what is chemical change, what is chemical reaction, and how many types of chemical equations are there. Because now in the next class we will study everything one by one in details. Clear? Because these are very sure to come in your exams. They are often asked every year. So we will study everything one by one in the details, but here today I'll just give you a brief example of what this reaction means. So we have a combination reaction, decomposition. The name plays a very important here. Though we have an example here, but the name plays a very important here. Combination, what? Combination means to combine. That means here we are going to add elements are going to combine. Now here, decomposition. Decomposition simply means breaking down. That means here one compound is going to break down to give two or more simple substance. Displacement, what do you mean by displacement? Displacing one another. Clear? And here we have double displacement. What do you mean by double displacement? That means here two elements they are going to exchange. Now exothermic and endothermic reaction. What does this reaction means? Exothermic, whenever exo comes to your mind, you have to remember this is releasing. Exo means releasing. So exothermic reaction means those chemical reactions which involve releasing of heat energy. Clear? And endothermic reaction. Endo means absorbing. Clear? So please keep this in mind. Exo, release, endo, absorbing. Clear? So those chemical reactions which involve the release of heat energy is known as exothermic, and those chemical reactions which involve the absorption of heat energy is known as endothermic reaction. In the next class, I'll be giving you a very practical example and chemical reaction as well. Now, next is redox reaction. Redox reaction is those chemical reaction where oxidation and reduction reaction take place simultaneously. Clear? Redox reaction is where oxidation and reduction reaction take place simultaneously. So please note this one down. Please note all these types of reaction one by one. This will save a lot of time. And since we're going to study everything in details in the next class, so please note this one down. Okay, so class, I'm sure you have noted down everything that we have studied today. And I will leave you with one question here, one equation. I'll give you a simple equation which I will solve in the next class. So it's like a homework for you. So what is Na? It's a chemical symbol for what? Sodium, right? Sodium reacts with, now we have H2O. That means water. So this gives sodium hydroxide, NaOH, and hydrogen gas. So this is the chemical equation. And now since this is the chemical equation as explained, I have explained, you know that this side is the reactant and this side is the product. Now, this is a homework for you. Try everyone. I will solve this in the next class so you can clarify it. So this is a sodium. This is water, you all know. This is sodium hydroxide, and then this is hydrogen gas. Clear? So everyone, please try this one at home. So we are done for today's class, and I would request everyone to follow up. Don't stop reading. Always continue. Always, even though you are at lockdown, please do continue your regular studies. So thank you. See you next class.